Let's solve this question here. A square is inscribed in a circle. If the area of the square is 100, what is the perimeter of the shaded region? So we're looking for the perimeter of these lines here. So it's this line here. We call that the arc, and this line here. So we're looking for the perimeter of the blue lines here. Now, right away, we do know that the perimeter of this horizontal line here, because it's given in the question. The question said, if the area of the square is 100, that means the area of this square is 100. And the length of all sides in a square are equal. So what's the area formula of a square? Assuming that one of this side length is L, so here we can say that L squared is equal to 100, right? That's the area of the square, right? Then take the square root of both sides. We have L equals to square root of 100. And of course, right, a side length has to be positive. So that will give me L equals to 10. So that means each of this side length is 10. That means this is 10. Okay, now we have the answer for the horizontal line, right? How about this arc here? How do we calculate the perimeter of this arc here? Now, right away, what I'm thinking about is that, right? What's the formula to calculate the length of an arc? Let's write here. Arc length that is S stands for the arc length is equal to the radius times the angle theta. Now, if I draw a diagonal line inside the square like this, connecting the two corners of the squares, is this diagonal line also the diameter of this circle here? This is very important. We need to know this. Okay, to think about this, let's rotate this diagram a little. So like this, right? It's rotated a little. Now, if I draw a horizontal line here like this, so this is the diagonal in the square. Same as this one here, but the diagram is rotated a little, like this, right? Yeah, okay, now, from this angle, we have to bring up one of the circle theorems. Okay, so in this circle theorem, this magenta line is the diameter of the circle. And if I draw a line connecting from like one end of this diameter up to a circle, and then draw another line connecting the other end of the diameter, what's the degree of this angle here? Okay, let me draw another line connecting this point here to the center of the circle. Notice that this side here is the radius of the circle. This side here is also the radius of the circle. And since this line is connecting from the center of the circle to the side of the circle, this is also the radius of the circle. So that's the radius, and that's the radius, right? So they all have equal lengths. What does that mean? That means this triangle here is an isosceles triangle. So this side and this side are the same, right? So that means this angle and this angle here are the same. Let's call this angle A and angle A here. Let's call this angle C. On this triangle here, this is also an isosceles triangle. So this side and this side are the same, right? So that means this angle and this angle are the same. So let's call this angle B and let's call this angle B. This angle we call angle D. Okay, now we're looking for the angle here, right? This full angle here, which is A plus B. What's this angle here? Now, to calculate what the angle A plus B is, we have to come up with some equations based on this. So, right here we know that all angles inside a triangle would add up to 180 degrees. So, A plus C is 180 degrees, right? So, 2A plus C. 2A plus C equals to 180 degrees. And then, in this triangle, same thing. B plus D is equal to 180 degrees. Then 2B plus D is equal to 180 degrees. So I can write that. 2B plus D is equal to 180 degrees. What else do we know? We know that this full angle here is 180 degrees, right? So C plus D is 180 degrees. So C plus D is 180 degrees. Okay, now let me erase this first for now. Now, with this, we have systems of equations. Let's solve for them. Okay, so if I add these two equations together, right? So here, right? If I add them, then I will have 2A plus C plus 2B plus D is equal to, the right side will be 180 degrees plus 180 degrees. So let's regroup this. So we have 2A plus 2B plus C plus D is equal to 360 degrees. Now, we know that C plus D is 180 degrees. So we can replace it into here, right? 180 degrees. So 2A plus 2B plus 180 degrees is equal to 360 degrees. Now, 2A plus 2B is equal to 360 degrees minus 180 degrees. 2A plus 2B is 180 degrees. And we have a common factor 2 here, right? So take it out. So we have 2 times A plus B equals to 180 degrees. Divide both sides by 2. A plus B is equal to 90 degrees. Okay, so A plus B is equal to 90 degrees, which is what we're looking for here, right? This angle, A plus B, is 90 degrees. So we can say that A plus B is equal to 90 degrees. Okay, now, it doesn't matter if I draw a line connecting to this point down here, or just right in the middle of the circle, right? And down here. This angle, right, between the two lines will be 90 degrees, as long as this line here is the diameter of the circle. Coming back to this diagram here, same thing, right? We know that all angles inside a square are 90 degrees, and each of them is 90 degrees. So that means this is 90 degrees, right? This angle is 90 degrees. Okay, so this is exactly, right, a line connecting from one end of the horizontal line up to the circle, and then there's another line connecting from this point down to the other end of the horizontal line. And this angle here between these two lines is 90 degrees, same as the circle theorem here, right? So that means this horizontal line, which is the diagonal line of the square, is also the diameter of this circle here. right? So in the original diagram, this diagonal is also the diameter of the circle here. Okay, that's good. This is a very useful piece of information that we need, right? To solve for this arc length here. Okay, the next thing is, now I will draw another diagonal line from this side of the square down to this side of the square. Okay, so what does it look like now? I mean here. Here, here, and here. Now this is a sector. Okay, so let me bring back the arc length formula, right? So S stands for the arc length is equal to R theta. Now, the radius will be from this point to this point, right? So here to here, that's the radius. And what's the theta? The theta is the angle here. So let's call this theta, right? So the length of the radius times theta is the arc length. Okay, first of all, how can we calculate theta? Okay, let's look at a triangle like this, a right triangle like this. Now we know that each of this side is 10, right? Because it's a square, right? Okay, so if this side is 10, this side is 10, what would be this angle here? We can use tangent law, right? So 10, this angle is equal to this side divided by this side. Let's call this angle alpha. So to calculate angle alpha, we can have 10 alpha is equal to 10 over 10, right? Each side is 10. That's equal to 1. That means alpha is equal to tangent inverse 1, and alpha is equal to 45 degrees. In radian, that's also pi over 4. Okay. So this one here is 45 degrees. So what's the angle here? Well, we can look at it from this triangle here, right? So 10, this angle is the same as this side divided by this side, and that's 10 divided by 10, which is 1. It's the same thing, so it's 45 degrees. How about this angle here? We can look at this triangle here, right? Same thing, 10, this angle is this side divided by this side, which is 10 divided by 10 is 1, right? Then this angle is 45 degrees. How about this angle here? We can look at it from this triangle here, right? So 10, this angle is this side divided by this side, which is 10 over 10 is 1, which is also 45 degrees. Okay, here. How about this angle here? We can look at this triangle here, right? 10, this angle is this side over this side, which is 10 over 10. Same thing, 45 degrees. How about this angle here? We can look at it from this triangle here, right? So 10, this angle is this side divided by this side, which is 45 degrees, right? How about this angle here? We can look at it as this triangle here, right? 10, this angle is this side divided by this side, which is 1, and this is also 45 degrees. How about this angle here? We can look at it as this triangle here, right? So 10, this angle is this side divided by this side, which is 10 over 10, which is 1, will give you 45 degrees here. Okay, so all these angle here are 45 degrees. Now, over here, this is one triangle. If this is 45 degrees, this is 45 degrees, then what's theta? Theta must be 90 degrees. Because we know that, right? All these three angles add up to 180 degrees. So theta plus 45 degrees plus 45 degrees is equal to 180 degrees. Then this is 90 degrees, right? equals to here. Now, theta is equal to 180 degrees minus 90 degrees, which is 90 degrees, right? Okay, so we know theta now. And in fact, these are all similar triangles. So that means this angle is theta, this angle is theta, and this angle is theta. Okay, so now we need to calculate the radius because we know theta now, but we don't know the radius, right? So what's the radius? Which is the length here, right? Okay, now I am going to draw another line here from the center, right? Here, the center. This is the center of the square, which is also the center of the circle here. I will draw it here like this, okay? To the side of the square here. Notice that, right? This is the center of the square. That means this line here is half the length of this side, right? And this length here is half the length of this full side here. So if we take, let's say, right, which is 10, right? So 10 divided by 2 is 5. So this side here is 5, this side here is 5. That means this is 5, right? So in other words, this side is also 5. Okay, so now notice that this is a right angle here. This is another right triangle. To calculate the radius, which is this side here, I can use the Pythagorean theorem, right? 5 squared plus 5 squared equals to r squared. So we call this r, the radius here. Okay, so that is r. That's also r here, right? So radius and radius. R squared is equal to 5 squared plus 5 squared. Now, 5 squared plus 5 squared is just 2 times 5 squared, right? So r squared is equal to 2 times 5 squared. Take the square root of both sides. 2 times 5 squared, right? Now, notice that the radius has to be positive. So we will take the positive value. So r is equal to, that is square root of 2 times 5. To rewrite this, r is equal to 5 square root of 2. Okay, now we have both the radius and the theta. So we can calculate the arc length here. This line here. Okay, so the arc length is S equals to r theta. And S is equal to r is this, 5 square root of 2 times theta. Now, theta is 90 degrees. That's what we calculated. Here. Here. And 90 degrees in radian is pi over 2. So times pi over 2. So the arc length is 5 square root of 2 over 2 pi. Now, what's the perimeter of this entire blue line here? So it's the arc length plus this horizontal line. And we did say that this horizontal line is 10, right? So the perimeter let me use blue here, right? Is equal to 10 plus the arc length, 5 square root of 2 divided by 2 pi. Okay, so that's the answer. To the perimeter of these blue lines here. An alternative way to calculate the arc length is this. As you can see here in this diagram here, notice that, right? These side lengths are equal. That also means that, right? The arc length here divided are all equal. That means these are 4 equal arc lengths here in the circle. And at the same time, right, the sector here is equal to the sector here, is equal to the sector here, is equal to the sector here anyway. So that means you can also see this as, right, this arc length here, you can see this as 1/4 of the entire circumference. Okay, here. An alternative way, right, to see that as this. The circumference formula is 2 pi r. And if you divide by 4, right, you get 1 of the arc length. And that is pi r over 2. Okay, what's the radius? We do know the radius as 5 square root of 2, right? And that means that's equal to 5 square root of 2 divided by 2, right? Pi times pi. Okay, so that's the arc length, right? Okay, and then of course you add the 10, right? So you get the same thing. So 10 plus 5 square root of 2 over 2 pi. Same answer. Hope you enjoyed this video. Don't forget to subscribe to my channel. Thank you.